Have a nice time. Today let us discuss some problems related to factor groups. First problem is find the order of the factor group set 6 over cyclic subgroup generated by 3. Here set 6 contains the elements 0, 1, 2, 3, 4, 5 and cyclic subgroup generated by 3 becomes set 0, 3 which is a subgroup of set 6. We have to find the order of this factor group set 6 over cyclic subgroup generated by 3. So here the group G equal to set 6 and the subgroup H equal to cyclic subgroup generated by 3. We have to find the order of the factor group G over H. That is, we have to find number of elements in the set of all cosets of H in G. We have already studied that all cosets of H in G contain same number of elements. Using this fact, we will find the order of the factor group set 6 over cyclic subgroup generated by 3. Here cyclic subgroup generated by 3 itself is a coset in set 6 over cyclic subgroup generated by 3. This coset is actually 0 plus the cyclic subgroup generated by 3. And we know that this coset contains 2 elements. Each of the other cosets of cyclic subgroup generated by 3 over set 6 contains 2 elements each. Then how can we find the number of cosets? It is enough to find order of set 6 divided by order of cyclic subgroup generated by 3. So that's equal to 6 by 2. The answer is 3. Here the 3 cosets are set 0, 3, set 1, 4 and set 2, 5. Likewise, if you find the order of G over H, it is enough to find order of G divided by order of H. Next problem is write all the elements of the factor group set 4 cross set 2 over cyclic subgroup generated by the element 2, 1. Also find the order of this group directly. So here set 4 cross set 2 contains 8 elements which are 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0 and 3, 1. Since set 4 contains elements 0, 1, 2 and 3 and set 2 contains the elements 0 and 1. Therefore set 4 cross set 2 contains these 8 elements. And here the subgroup H given us cyclic subgroup generated by the element 2, 1. First of all, we have to find all the elements in this factor group. That is, we have to enumerate all the cosets of this factor group. First coset is the cyclic subgroup generated by 2, 1 itself. One of the elements is 2, 1 itself. And to get next element, we have to add 2, 1 plus 2, 1. When we add these two elements, we have to add this in such a way that first coordinates we are adding with respect to the operation in set 4. That is, we have to add 2 addition modulo 4, 2. And the next coordinate belong to set 2. So we have to apply the operations addition modulo 2. That is 1 addition modulo 2, 1. So the answer becomes 2 plus 2 is 4. 4 when divided by 4, the remainder is 0. And 1 plus 1 is 2. 2 when divided by 2, the remainder is 0. So next element of this cyclic subgroup is 0, 0. So if we add again the element 2, 1, we will cyclically obtain these two elements repeatedly. So cyclic subgroup generated by 2, 1 contains these two elements and this is one of the cosets of this factor group. So this coset covers the elements 0, 0 and 2, 1 in set 4 cross set 2. Now we will search for an element in set 4 cross set 2 which doesn't belongs to this coset. So let it be 0, 1. So next coset is 0, 1 plus cyclic subgroup generated by 2, 1. That is, we are adding 0, 1 to each of the elements of this cyclic subgroup. That is 0, 1 plus 2, 1 becomes 2, 0. Addition should be performed as I just explained. And 0, 1 plus 0, 0 gives 0, 1. So the next coset contains the elements 0, 1 and 2, 0. Now we will take one of the elements in set 4 cross set 2 which are not in both of these cosets and let it be 1, 0. So next coset is 1, 0 plus cyclic subgroup generated by 2, 1. So this is equal to 1, 0 plus 2, 1 gives 3, 1 and 1, 0 plus 0, 0 gives 1, 0. So this 1, 0 and 3, 1 are also covered. And what remains? We can choose the element 1, 1 from set 4 cross set 2 and next coset is 1, 1 plus cyclic subgroup generated by 2, 1 and this is equal to 1, 1 plus 2, 1 gives 3, 0 and 1, 1 plus 0, 0 gives 1, 1. When add these two elements, we have to perform the operation explained here. So we covered all the elements of set 4 cross set 2 using these 4 cosets. Thus the order of the factor group set 4 cross set 2 over cyclic subgroup generated by 2 1 equal to 4, since this factor group contains 4 different cosets. Now let us try to answer the question directly. If you want to find the order of the factor group set 4 cross set 2 over cyclic subgroup generated by 2 1, it is enough to find the order of set 4 cross set 2 divided by order of the cyclic subgroup generated by 2 1. So this is equal to set 4 cross set 2 contains 4 into 2, that is 8 elements, and cyclic subgroup generated by 2 1 contains 2 elements, which are 2 1 and 0 0. So the answer is 8 by 2, that's equal to 4. So in this direct way also we can find the order of the factor group. Now we have to find the order of the factor group set 12 cross set 18 over cyclic subgroup generated by 4 3. Let us find the answer directly. Order of set 12 cross set 18 over cyclic subgroup generated by 4 3 equal to order of set 12 cross set 18 divided by order of cyclic subgroup generated by 4 3. You can find the order of set 12 cross set 18 easily. It is 12 into 18 clearly. And we have to find the order of the cyclic subgroup generated by 4 3. Actually, order of cyclic subgroup generated by 4 3 equal to order of the element 4 3 in set 12 cross set 18. That is, here we have to find the least positive integer n such that 4 3 raised to n becomes 0 0, which is the additive identity in set 12 cross set 18. If we add the first coordinate 4 3 times, it becomes 0 in set 12, because 4 plus 4 plus 4 equal to 12, which is equal to 0 in set 12. That is, order of the element 4 in set 12 is 3. Likewise, if you add the second coordinate 3 6 times, then only it becomes 0 in set 18. That is, order of the element 3 in set 18 is 6. Since order of 4 in set 12 was 3, we can conclude that 4 raised to 3 equal to 0, 4 raised to 6 equal to 0, 4 raised to 9 equal to 0, etc. That is, 4 to the power any multiple of 3 becomes 0. Likewise, since order of 3 in set 18 is 6, we can conclude that 3 raised to 6 equal to 0, 3 raised to 12 equal to 0, 3 raised to 18 equal to 0, etc. That is, 3 to the power any multiple of 6 equal to 0. Here the least positive integer n such that both 4 raised to n equal to 0 and 3 raised to n equal to 0 simultaneously is n equal to 6. Actually, to find the order of 4 3, we are searching for the LCM of order of the element 4 and the order of element 3 in the respective groups. So here the answer equal to set 12 cross set 18 contains 12 into 18 elements, and order of the cyclic subgroup generated by 4 3 is LCM of order of 4 in set 12, which is equal to 3, and order of 3 in set 18, which is equal to 6. So this equals 12 into 18 divided by LCM is here 6. So the answer is 36. So this factor group contains 36 cosets. Now you can easily find the answer of this question. Find the order of the factor group set 2 cross set 4 over cyclic subgroup generated by the element 1 1. This is equal to order of set 2 cross set 4 divided by order of the cyclic subgroup generated by 1 1. So this is equal to 8 divided by LCM of order of 1 in set 2, comma order of 1 in set 4. So the answer becomes 8 divided by order of 1 in set 2 is 2. So we have LCM of 2, comma order of 1 in set 4 is 4. So the answer is 8 by 4, which equals 2. Let us have one more problem of the similar kind. Find the order of set 2 cross S3 over cyclic subgroup generated by 1, comma row 1. Here 1 belong to set 2 is of order 2. and row 1 belong to S3 is of order 3. Since cyclic subgroup generated by row 1 contains the elements row 1, row 2, row 0 in S3. So clearly order of set 2 cross S3 over cyclic subgroup generated by 1 row 1 equals order of set 2 cross set 3 divided by LCM of order of 1 in set 2 and order of row 1 in S3, which equals 2 into 6 divided by LCM of 2 and 3. Since set 2 contains 2 elements and S3 contains 3 factorial, that is 6 elements, and order of 1 in set 2 is 2 and the order of row 1 in S3 is 3. So we get the answer 12 by 6, which is the LCM of 2 and 3 is 6. So 12 by 6 equal to 2. So this particular factor group contains 2 elements. In the next class we will find the order of some elements in given factor groups. See you in the next class.